Very good morning. Today we are going to see a simple problem on RL series circuit. Already we have seen similar kind of problems, but here today we are going to solve it by using a solve, and also we are going to attain the impedance triangle and as well as the power triangle. Take down this problem. A coil having a resistance of 7 ohms and an inductance of 31.8 millihenries is connected to 230 volts 50 hertz single phase AC supply. Calculate first one current flowing to the circuit, second one is power factor, third one is power consumed by the circuit, and fourth one is draw the impedance triangle and power triangle. So first, what are the given terms? R is 7 ohms and inductance is 31.8 millihenries. Voltage is 230 volts, 50 hertz. So first we need to draw the circuit. We need to frame the circuit by using the problem. So given data is R and L. So that is in series circuit. Okay, is connected to 230 volts 50 hertz AC supply. So 7 ohms and 31.8 milliamperes. Okay, so it is connected to 230 volt 50 hertz AC supply. So first what they asked, first we need to calculate what is the current flowing to the circuit. So current flowing to the circuit, how to calculate current flowing? Simply by using the Ohm's law. So by using the Ohm's law, I is equal to V by Z, or V is equal to I into Z. So V we know, V is 230 volts. So Z we need to calculate. Impedance Z we need to calculate. So Z is equal to root of R squared plus XL squared. So from the power triangle, already we have seen how to derive the Z. Okay, Z is equal to root of R squared plus XL square, or otherwise Z squared is equal to R squared plus XL square. Either it is same. So now resistance value we know, but only inductance value only will is given in the problem. Now we need to calculate what is the inductive reactance of the coil. So inductive reactance, how to calculate? XL is equal to omega F. So omega is nothing but 2 pi F into L. So if you calculate 2 into pi into F is 50 hertz and the inductance is given as 31.8 millihenries. Okay, so milli means 10 to the power of minus 3. So if you simplify this, XL we got it as 9.9852 ohms. Now we are substituting XL over here, that is inductive reactance over here, and simplifying. So simplifying will get the impedance Z as 12.19 ohms. Now we can easily calculate what is the current. So current is equal to V by Z. So V is 230 volts divided by Z, what we impedance what we calculated is 12.19 ohms. So if you simplify, we can easily get what is the current flowing to the circuit. That is I is equal to 18.86 amperes. Now, what is the second thing? What is asked in this problem is power factor. We need to calculate what is the power factor. So power factor we need to calculate. Next, third one is what is the power consumed by the circuit. So first we'll calculate power consumed, then we'll go for the power factor. Either way is same. So power consumed by the circuit is nothing but I squared R. I squared R, or otherwise it is VA cos phi. Either the same answer only you'll get. How the same answer will get na real power or true power or active power? P is nothing but P is equal to VA cos phi. So cos phi is what? Cos phi we already derived. Cos phi is equal to R by Z. So if you simplify, if you substitute for V, so V is nothing but I into Z by using the Ohm's law. So if you simplify further, so Z and Z will get cancelled. So it is I squared R. So power consumed is I squared R, or otherwise VA cos phi. So here we are taking power consumed as per from the previous problems. We are taking power consumed as I squared R. So the same thing we are taking I squared R. So you can also take VA cos phi also. Same answer only will come. So I squared R is, so I is what we calculate is 18.86 ampere squared into resistance. Resistance is given in the problem as 7 ohms. So if you simplify this, we are getting the answer as 2489.89 watts. That is the power consumed by the circuit. Next is power factor. So what is power factor? Power factor is nothing but cosine of the angle between the voltage and current. So in other terms, it is cos phi is equal to R by Z. Okay. So R by Z, that is resistance by impedance. So resistance is given in the problem as 7 ohms, and the impedance we calculated. Impedance we calculated as here, impedance we calculated as 12.919 ohms. So 12.19 ohms we are just substituting over here, and we are calculating what is cos phi, that is power factor. So if you calculate cos phi, we are getting this 0.574. Now we are calculating what is the phase angle. Phase angle phi is equal to cos inverse of 0.574. So here phi we are getting as 54.97 degree. So that is lagging. So why it is lagging? Because of the inductance load, it is lagging. So that is phi is equal to 54.97 degree lagging. Okay. Now what is asked in the problem? Next thing they asked is draw the impedance and power triangle. So impedance triangle is very simple that we have seen. So impedance triangle is nothing but a right angle triangle that visually represents the relationship between the resistance, reactance and impedance. So reactance and impedance. So if you see the impedance triangle, it is a right angle triangle. So here the hypotenuse side is the impedance Z, and the opposite side is inductive reactance XL, and the adjacent side is resistance. Okay, so this is the phi. Phi is nothing but the phase angle. Okay, phase angle we calculated, no, that is 54.97 we calculated, that is the phase angle. Now we need to, so already we calculated all these values. Z we know, inductive reactance we know, and the resistance also know. So from the previous formulations, Z we calculated, XL we calculated, and resistance also from the problem we know. Now, just substituting the value. So, Z is equal to 12.19 ohms, and then the resistance R is equal to 7 ohms, and the inductive reactance XL is equal to 9.9852 ohms. Okay, so what is the phase angle phi? Phase angle phi is 54.97 degrees. So, that is all about the impedance triangle. Now, what is asked in the problem is power triangle also asked. So for calculating the power triangle, we need to calculate the three factors. That is, one is true power or real power or active power, that we need to calculate. That is power. What is the formula for a real power or a true power or active power is VA cos phi. So VA cos phi. So we know 230 volts. I we calculated 18.86, and cos phi also we calculate as 0.574. So if we simplify, we are getting the real power as 2489.89 watts. Now we need to calculate what is the reactive power. So reactive power is unused power that is flowing throughout the circuit. So true power is what? True power is whatever the power we generated. That is called the true power. Okay. So reactive power. So what is the unit for true power is watts. Okay. So reactive power is VI sine phi. So VI sine phi, so phi we know, sine into that phi we are substituting over here, 54.97. So if you simplify, we are getting the answer as Q is nothing but 3552.01 VAR. The unit of reactive power is voltage, ampere and reactive. That is the unit of reactive power. Next is the resultant apparent power. Apparent power S is equal to V into I. So V is what? 230 volts into I is 18.86. So if you simplify, we are getting the answers 4337.8 voltage ampere. So this is a unit for apparent power. Now we are going to frame the power triangle. So power triangle, this hypotenuse side is apparent power. Okay, so real power is adjacent side and reactive power is opposite side. So real power, what is the formula? Power is equal to VI cos phi. The unit of real power is watts. What is reactive power? Reactive power is Q. Okay, so Q is nothing but VA sin pi. The unit is VAR, voltage ampere reactive. So what is apparent power? Apparent power is V into I. The unit of apparent power is V into VA. Okay, so real power we calculated here, reactive power also we calculated, and apparent power also we have calculated. Just substituting here. So power P is equal to 24 to 2489.89 watts, and here S is equal to 4337.8 VA, and Q is reactive power Q is equal to 3552 VAR. So what is the phase angle phi? So phase angle phi also already we calculated. Here 54.97, that is lagging. So here we need to substitute that 54.97 degrees. That's all. So that is all about the power triangle. So very simple problem. Easily you can get full marks from this particular problem. So here power triangle, but the units are very, very important. So unit of real power. Real power is whatever the we are generating. Generated power is real power. So reactive power is unused power that will flows through and flow from the sending end to receiving end. Okay, from the load to generating station, and this is the apparent power. Resultant is apparent power. So that is all about the power triangle. So units are very, very important. Without the units, the marks will be reduced. And here also the impedance triangle. So impedance resultant is Z, and the opposite side is inductive reactance XL, and the adjacent side is resistance. That is all about the impedance triangle. So from this only we are calculating what is cos phi. Okay, so cos phi is equal to cos phi is equal to adjacent by hypotenuse, no? So it is R by Z. Okay, so like that we are going to calculate um, the power factor also. Okay, so this is all about the impedance triangle. Next power factor, and the power consumed also, I squared R, or otherwise VA cos phi. Both will give you the same answer. And current flowing as usual by using the Ohm's law. I is equal to V by Z. So easily you can solve this problem, and you can get the full marks from this particular problem.